Hello dear friends, this is our second video regarding concept of remainder. So today we will learn about these type of questions as we discussed in our last video, like what will be the remainder when 19 raised to power n divided by 16 where n is equal to 23 raised to power 34. And these are the kind of questions you may please have a look that we have to discuss today. Last questions are very good. So let us start. What will be the remainder when 19 raised to power n divided by 16 where n is equal to 23 raised to power 34? Since 19 is congruent to 3 mod 16, so therefore 19 raised to power n is congruent to 3 raised to power n mod 16. Now we will see the pattern of 3 as a power of 3 and the remainder obtained after dividing by 16. Let's say 3 raised to power 1 leaves the remainder of 1 when divided by 16, so it is 3 raised to power 1 is congruent to 3 mod 16. 3 square is congruent to 9 mod 16. 3 cube is congruent to 11 mod 16. 3 raised to 4 is 81, which leaves remainder of 1, so it is 1 mod 16. So instead of writing 3 raised to 4 as 81, it's better to use in the third step as 3 cube is 27, which is 11 mod 16. Just multiply both sides by 3. So what we get is 3 raised to 4 on the left hand side, right hand side is we get 33, and 33 remainder obtained after dividing by 16 is 1. Similarly, if I multiply both sides by 3, what we get is 3 raised to 5 is congruent to 3 mod 16. Again multiply both sides by 3, this is 3 raised to 6 is congruent to 9 mod 16. 3 raised to 7 is congruent to 11 mod 16. 3 raised to 8 is congruent to 1 mod 16. So what we see here is it follows the pattern of 4. Like if we divide 5 by 4, remainder is 1, so both leave the same remainder as 3. 3 raised to 6 behaves as 3 raised to 2. 3 raised to 7 behaves as 3 cube. 3 raised to 8 behaves as 3 raised to 4. So what we observe is 3 raised to 4k plus 1, that is the numbers of the form 4k plus 1 in parts, leaves the remainder 3 when divided by 16. 3 raised to 4k plus 2 is congruent to 9 mod 16. 3 raised to 4k plus 3 is congruent to 11 mod 16. 3 raised to 4k is congruent to 1 mod 16. So now we see how 23 raised to 34 leaves the remainder when divided by 4, because 3 powers of 3 behaves this kind of a pattern. So now 23 is congruent to minus 1 mod 4. Raising both the sides as 34, what we get is 23 raised to 34 is congruent to 1 mod 4. That is 23 raised to 34 is of the form 4k plus 1. Now here 3 raised to power n, where n is equal to 23 raised to 34, which is of the form 4k plus 1. So therefore 3 raised to power n is equal to 3 raised to 4k plus 1 is congruent to 3 mod 16. So as per the given question, 19 raised to power 23 raised to power 34 is congruent to 3 raised to power 23 raised to power 34 is congruent to 3 mod 16. That is the remainder is 3. So next question. Find the remainder of 32 raised to power n when divided by 9 where n is equal to 37 raised to power 32. Since 32 is congruent to 5 mod 9, raising both the sides as power of n, that is 32 raised to power n is congruent to 5 raised to power n mod n. Now we observe the pattern of 5 as we had done in our previous question. That is 5 raised to 1 is congruent to 5 mod 16, 5 mod 9. 5 square is congruent to 7 mod 9. 5 cube is congruent to 8 mod 9. 5 raised to 5 is congruent to 2 mod 9. 5 raised to 6 is congruent to 1 mod 9. We will do until we observe a pattern. Here we get the pattern after the 6. That is, if we get the remainder as 1, if we multiply both sides by 5, again 5 raised to 7 leaves the remainder 5. 5 raised to power 8 leaves the remainder 7. 5 raised to power 9 leaves the remainder 8, and so on. That is what we get is 5 raised to power 6k plus 1. That is numbers of the form 6k plus 1. That is powers which are of the form 6k plus 1 leaves the remainder 5 and divided by 2. Likewise 1, 7, 13 and so on. 5 raised to power 6k plus 2 is congruent to 7 mod 9. 5 raised to power 6k plus 3 is congruent to 8 mod 9. 5 raised to power 6k plus 4 is congruent to 4 mod 9. 5 raised to power 6k plus 5 is congruent to 2 mod 9. 5 raised to power 6k is congruent to 1 mod 9. Now our aim is to calculate the remainder obtained after dividing 37 raised to 32 by 6, because we got the pattern after 6. The power is 37 raised to 32. So now here 37 is congruent to 1 mod 6. Raising both the sides as power of 32. What we get is 37 raised to 32 is congruent to 1 mod 6. Therefore 36, that is 37 raised to 32 is of the form 6k plus 1. So 5 raised to 37 raised to 32 is of the form 5 raised to 6k plus 1, which leaves the remainder 5. So what we get is, this is 5 mod 9. Now that is 32 raised to 37 raised to 32 is congruent to 5 raised to 37 raised to 32 is congruent to 5 mod 9. So the remainder obtained is 5 here. Next question is, we have to find the remainder after dividing 40 raised to 9 n by 11, where n is equal to 17 raised to 22. Since 14 is congruent to 3 mod 11, that is 14 leaves the remainder 3 when divided by 11. Therefore 14 raised to power n is congruent to 3 raised to power n mod 11. Now we see the pattern of 3 now, because we get 3 on the right hand side. Therefore 3 raised to 1 is congruent to 3 mod 11. 3 square is congruent to 9 mod 11. 3 cube, that is 27, which leaves the remainder 5 mod 11. So 3 raised to 4, again multiply both sides by 3, that is 3 raised to 4 is 3 into 5 15, which leaves the remainder 4 mod 11. 3 raised to 5 multiply both sides by 3, we get right hand side as 12. 12 is congruent to 1 mod 11. Therefore second order is 5, because after getting the 1 we get the same change, same pattern. Now here second order is 5. So now our aim is to find the remainder after dividing by 5. Now I am having a suggestion here. It's better to find the unit digit of 17 raised to 22 and then divide that unit digit by 5. For example, if we get the remainder unit digit as in that 1, 2, 3 or 4, then the same is the remainder. If we get remainder as 5, then remainder is 0. If we get the unit digit more than 5, say 6, 7, 8, 9, divide that unit digit by 5. That is, if we divide 6 by 5, we get remainder 1. We get 7. If we have the unit digit is 7, if we divide that digit by 5, we get the remainder 2. So we can easily get the remainder after dividing by 5 only by seeing the unit digit of any number. So here unit digit of 17 raised to 22 behaves as 7 raised to 22. Since 7 has a chain of 4, so we get behaves as 7 square, that is 7 square is 49, which is unit digit is 9. Now divide this unit digit 9 by 5, we get the remainder as 4, that is 17 raised to 22 leaves the remainder 4 when divided by 5, that is it is of the form 5k plus 4. That is 17 raised to 22 leaves the remainder 4 after dividing by 11. That is now here 14 raised to 17 raised to 22 is equal to 3 raised to 17 raised to 22. That is which is of the form 3 raised to 5k plus 4, which leaves the remainder 4 mod 11 for after dividing by 11. We can get the remainder as above we have done in the previous question. That is we have to divide 17 raised to 22 by 5. Since 17 is congruent to 2 mod 5, 17 raised to 22 is congruent to 2 raised to 22 mod 5. Since 2 raised to 4 is congruent to 1 mod 5, 2 raised to 20 again raised to power 5, we get 1 mod 5. Multiply by 2 square, that is 2 raised to 22 is congruent to 4 mod 5. That is 17 raised to 22 is congruent to 4 mod 5. That is 17 raised to 22 is of the form 5k plus 4. So what we get here now, next question is, we have to find the remainder of 38 raised to power n when it is divided by 11, where n is equal to 33 raised to power 39. So 38 is congruent to 5 mod 11. 38 raised to power n is congruent to 5 raised to power n mod 11. Now look at the pattern of 5. 5 raised to power 1 is congruent to 5 mod 11. 5 square, that is 25, is congruent to 3 mod 11. Multiply both sides by 3, it's easy. So 5 cube is congruent to 5 into 3, 50, which leaves the remainder 4. It is 4 mod 11. Again multiply both sides by 5. 5 raised to 4 is congruent to 9 mod 11. 5 raised to 5 is congruent to 1 mod 11. Again cycle order is 5. That is after 5 they are repeating. So it is easy to calculate the unit digit. But keep this in mind. This is true only in case of 5 and 10. That is, if we get the cycle order of 5 or 10, then only we can take the unit digit. Otherwise, we have to do the previous method. Now here 33 raised to power 39, which is n, is behaves as 3 raised to 39 as a unit digit. Now 3 also has a pattern of 4, so divide 39 by 4, we get a remainder 3. So it behaves as 3 cube, which is 27. So unit digit is 7. Now divide this 7 by 5, we get the remainder as 2. That is 33 raised to power 39 is of the form 5k plus 2. So 38 raised to power 33 raised to power 39 is congruent to 5 raised to power 33 raised to power 39, which is of the form 5k plus 2. It is 5 raised to power 5k plus 2, which leaves the remainder 3 when divided by 11, so it is congruent to 3 mod 11. So net answer is 3 mod 3, remainder is 3. Now you have to find the remainder when 31 raised to power n is divided by 9, where n is equal to 31 raised to power 31. Since 31 is congruent to 4 mod 11, 4 mod 9, raising both the sides as n, that is 31 raised to power n is congruent to 4 raised to power n mod 9. We see the pattern of 4 now. 4 raised to power 1 is congruent to 4 mod 9. 4 square is congruent to 7 mod 9. 4 cube, that is 64, which is congruent to 1 mod 9. So cycle order is here 3. Now our aim is to obtain the remainder after dividing by 3. So 31 is congruent to 1 mod 3. Raising both the sides as 31, we get 31 raised to power 31 is congruent to 1 mod 3. Now that is 31 raised to power 31 is of the form 3k plus 1. So 31 raised to power 31 raised to power 31 is congruent to 4 raised to power 31 raised to power 31, which is of the form 4 raised to power 3k plus 1, which leaves the remainder 4 after dividing by 9. So the net answer is 9. Net answer is 4. Sorry. So next question is, you have to find the remainder when we divide 30 by 8. You thought that why I had put this question. You can say that this is a very simple question. That's 30 can be written as 3 into 8, 24 plus 6 is the remainder. So you are thinking that why I had put this question, because I want to introduce a new concept, a very beautiful concept, that is, if we write 30 by 8 and when we divide we get 15 by 4, but we divide by 2. Now keep this 2 to the side. Keep this 2 to the side, we get the remainder 15 by 4. Now see the remainder of 15 after dividing by 4. It's easy. Remainder is 3. Now multiply this 3 by the previous 2. That is 2 into 3, which comes out to be 6. Okay. I'm repeating again. Initially 30 by 8. Just take 2 outside from the numerator and denominator. Then you can say that you can take the HCF of numerator and denominator here. Take 2 outside. What we get remainder is 15 by 4. Okay. Now divide 15 by 4, we get the remainder as 3. Multiply this 2 by 3, we get 6, which is the net remainder. Now we use this concept in the next questions. Find the remainder of 17 raised to power 193 when it is divided by 51. Now we can write 17 raised to power 193 as 17 into 17 raised to power 192. We have to divide it by 51. Now 17 divides 51. Just take 17 as common, or you can divide numerator and denominator by 17. We get 17 raised to 192 by 3. Now it is easy to find the remainder after dividing by 3 rather than 51. That's why I use this concept. So 17 is congruent to minus 1 mod 3. 17 raised to 192 is congruent to 1 mod 3. That is remainder is 1. Now net remainder is 17 into 1, which is 17. Now find the remainder when 4 raised to 100 is divided by 100. So when we divide by 100, it is same as to find the last 2 digit of the number, that is 4 raised to 100. So which we learn in our next video, how to find the last 2 digit of a number. I am sure that to finding the last 2 digits of this number is much better, you can say much easier by doing this question. That is, we can obtain the remainder by 100 by using the last 2 digit method, which I will use in my next video. So you will learn how in seconds, or you can say minute, hardly maximum 1 minute, you can find the unit digit of any number. So we will learn that in the next video. So now here I am using the same concept. We can write 4 raised to 100 as 4 into 4 raised to 99. We have to divide by 100. Just divide numerator and denominator by 4. What we get is 4 raised to 99 by 25. You can write 4 raised to 99 as 2 raised to 198. We have to divide it by 25. Since 2 raised to 10 is 1024, which leaves the remainder minus 1. You can say which is congruent to minus 1 mod 25. raising both the sides is 19. What we get is 2 raised to power 190 is congruent to minus 1 raised to power 19, which is congruent to minus 1 mod 25. Now 2 raised to power 8 is 256, which is congruent to 6 mod 25. When we multiply these two, what we get is 2 raised to power 198 is congruent to minus 6 mod 25. That is minus 6 is same as 19 mod 25. But the net remainder is 4 into 19. 4 is that number when we divide it in the initially. So the net remainder is 76. Next question is, find the remainder of 65 raised to power n divided by 39, where n is equal to 39 raised to power 80. So here we can write 65 raised to power n by 39 as 65 into 65 raised to power n minus 1 divided by 39. So now we can divide numerator and denominator by 13. So keep this 13 outside. Okay. So what we get is 5 into 65 raised to power n minus 1 by 3. So 65 is now congruent to minus 1 mod 3 raised to power n minus 1. What we get is 65 raised to power n minus 1, which is congruent to minus 1 raised to power n minus 1 mod 3. So now here n is 39 raised to power 80. 39 is an odd number. It means odd raised to power even. Means odd is multiplying even number of times, but the net answer will be odd. So n is odd here. Therefore n minus 1 is even. Therefore 65 raised to power n minus 1 is congruent to minus 1 raised to power even, which is 1 mod 3. Now also 5 leaves the remainder 2 when divided by 3. That is 5 is congruent to 2 mod 3. Multiply these two. What we get is 5 into 65 raised to power n minus 1 is congruent to 2 mod 3. But the net remainder is, multiply that 13 into this 2. We get 13 into 2, 26 as the net remainder after dividing by 39. Next question is, we have to find the remainder when 85 raised to power n is divided by 51, where n is equal to 19 raised to power 53. We can write 85 raised to power n as 85 into 85 raised to power n minus 1. Since you can divide numerator and denominator by 17, the maximum number you can divide from. So this is 7. Take 17 outside and keep 17 in mind. So we get 5 into 85 raised to power n minus 1 by 3. Because now it is easy to find the remainder when by 3 rather than when we divided by 51. So we can write 85 is congruent to 1 mod 3. 85 raised to power n minus 1 is congruent to 1 mod 3. So 5 is also congruent to 2 mod 3. So 5 into 85 raised to power n minus 1 is congruent to 2 mod 3. Now here, since we get right side as 1, so we need not to check whether n is even or odd, because raised to power any power of 1 raised to power n is always 1. So here 5 into 85 raised to power n minus 1 is congruent to 2 mod 3. But the net remainder is, multiply that 17 by this 2, we get 17 into 2 is 34. So net our answer is 34. Now we are getting the two beautiful problems here. You have to find the last two digits of this number, 67 into 53 into 23 into 17 into 79 into 31 into 35. You are thinking that how we will do this question. So last two digit means when we divide the number by 100. So we can write here 67 into 53 into 23, 17 into 79 into 31 into 35 by 100. Now what we are looking here is only 35 is the number which have a factor common with the 100. So here we can divide both sides by 5 and keep this 5 as in our mind. So we get 5 7 the 35, 5 here is 20. Now the beautiful result is, it's easy to get the remainder when divided by 20. That is, if we divide 67 by 20, we get the remainder as 7. If we divide 53 by 20, either we get the remainder as 13 or you can write as minus 7. We will use as per our convenience as discussed in our previous video number the concept of remainder part 1. So we divide 23 by 20, remainder is 3. After dividing 17 by 20, we get remainder as minus 3. When we divide 79 by 20, we get remainder as minus 1. It is easy to calculate by minus 1. So 31 is divided by 20, we get the remainder as minus 9. You can use 11 as per your convenience. So, and next the 7 here. Now 7 into 7 is minus 49. 3 into minus 3 into minus 1 is 9. Minus 9 into 7 is minus 63. So minus 49 again, when we divide this by 20, we get as minus 9. Again this is 9, then this is minus 63 means minus 3. Negative is positive, we get here 9 9 the 81. 81 into 3 by 20. 81 leaves the remainder 1, we get 1 into 3. So net here remainder is 3. But the net remainder is 5, which is we get in the initial stage. So 5 into 3, we get the net answer is 15. You can check this by calculator, then you will feel amazed. So next last question is, find the last two digits of 37 into 18 into 57 into 87 into 63 into 45 into 29. We have to find the last two digits. Again we divide it by 100. Now here what we see is 18 as well as 45 has the common factor with 100. So we divide first 5 9 the 45, 5 this is the 20. So again we can divide 2 9 the 18 and 2 10 the 20. 2 into 10 20. So net now in denominator we get the S10. Now we get the remainder after dividing it by 10, which is quite easy. You can see the unit digit as well, or you can take the congruent modulo's help. So when divide 37 by 10, we get remainder 7. 9 leaves the remainder -1. 57 you can write as -3. 87 as 7. You can write as -3 as well as per your convenience. 63 as 3. 9 as again -1. 29 as again -1. So what we get is 7 into -1 into -3. That is 21. Again 21. This is 1. So 21 leaves the remainder 1. 21 again leaves the remainder 1. So net remainder is 1. So net remainder, because earlier we had divided 5 and 2 both here. So 5 into 2 is 10. So we get is 10 into 1, which is 10. Thank you. Have a nice day.